Audio Jungle. Audio Jungle.
Right. So next topic what we have here, it's aerodynamic coefficient. Coefficients. How many coefficients you know? How many coefficients you know? Generally, we have three. Lift coefficient denoted by CL, then coefficient and third one is moment coefficient. Yes or no? So again this is denoted by Cm. So basically what will happen, this again this I must say this coefficient, moment coefficient again will have a three types. Okay, it's called pitching moment coefficient. Okay, so rolling moment coefficient and yawing moment coefficient. Okay, so now, so again there is like pitching moment coefficient, rolling moment coefficient, yawing moment coefficient. It comes from different axes, longitudinal axis, directional axis and normal axis. Okay, so generally moment coefficient we said, so it's the pitching moment coefficient. Pitching moment coefficient means nose up and nose down. Okay, so in fact whenever aircraft is what suppose flying, so it may go for nose up or nose down, passenger aircraft. Okay, I am saying obviously there will be normal, there will be a rolling moment also and yawing moment also. Rolling obviously it will be very less in case of passenger aircraft, but in case of military aircraft definitely rolling moment will be there. So what I want to tell you, like in case of passenger aircraft, most of time frequently you can say will get pitching moment coefficient. Okay, so so overall here I have mentioned moment coefficient, and it is nothing but Cm, pitching moment coefficient must say. Okay, that will be the moment coefficient. Here it will be denoted by Cm, and this Cm is nothing but moment coefficient, but generally it is pitching moment coefficient. I hope you all understood this. Okay, fine. Now we'll go for this. We can say here we have the airfoil. Okay, and this airfoil is what at some angle. Okay, so I must say this is what airfoil here. This is what airfoil. Okay, and for this airfoil, definitely one will be the chord line. Okay, one will be the chord line. So I must say, because this is what chord line, and that chord line, okay, from the relative wind, because it's now at flying at some angle, so need to say that where is the angle of attack. So we just say this is what relative wind. Okay, what it is called? Relative wind. And this is what? Chord line. Angle between chord line and relative wind is nothing but alpha. Okay. What is the alpha? Alpha is the angle of attack. Okay. Now here we have a flow velocity. Say free stream air, you can say, which is nothing but V infinity. Okay. So you all know somewhere in the middle of, or you can say at some quarter chord length, there will be one point, and at this point, this is the part of the stability. When I will explain stability, you may get like what is the like center of pressure, or in fact aerodynamic center. All right, and as here like angle of attack. Okay, or effective angle of attack, everything will be explained there. Here in short, I just wanted to tell you how many number of aerodynamic coefficients and how you may get that. Okay, in short. So I have taken one point, which is nothing but you say this is the one point where all the forces are acting. Okay. So generally it is aerodynamic center and center of pressure. Okay. Center of pressure you may take for the whole wing, and aerodynamic center you will talk for the wing alone. So here I am considering this is the one wing. Okay, and the cross section of wing is nothing but airfoil. So basically here I have taken one airfoil, right? Now this is the one point where I am going to show you all the forces. So first I will say what is the lift force. So perpendicular to the relative wind will be what? Lift force. So this is the relative wind. Okay, this is the relative wind. So perpendicular to this we have lift force. Okay, parallel but just opposite. Okay, parallel but just opposite to the like this is the relative wind, but in which direction that aircraft motion will be? In forward direction. So just opposite to the forward motion will have a one force called drag force, and it will be parallel to relative wind. Okay, parallel to relative wind. So this is what drag force. Okay, D. Perpendicular to this relative wind will be what? Lift. It will be denoted by L. Okay, now I can say there will be one, obviously you will show the resultant force somewhere. So this will be R. Okay, and at this point there will be moment, force, moment, not force, moment. Okay, C by 4 means at quarter chord. I will explain when stability and all. I will tell you 50% of chord, quarter chord, what is the aerodynamic center, what is the center of pressure, everything. In short, just say this is the one point called P. At this point P, all the forces, basically aerodynamics force and moment. Aerodynamic forces are lift and drag, and moment is pitching moment basically. So three things you have seen here. One is lift force, another is drag force, and third one is the moment. Okay. Lift force, drag force, and moment. This will be the diagram. All right. Up to here it is very clear. So now you understood what is the lift. Lift is generally the force perpendicular to the relative wind. Okay. And this whole length is nothing but chord. Okay. From leading edge to trailing edge. That already I had explained in last class. Huh? C is the chord length. All right. So in very short, I am just explaining this part, so it will be more clear to you. Done. Finally, check. Just like the lift and drag, I have explained you. Lift is what it is perpendicular to relative wind. Similarly, drag is parallel to relative wind. Okay. Moment about point P. Okay, which is at which is at quarter chord. Okay. And one more very special point here, it is alpha. Alpha is angle of attack. Okay. Done. Now so if you check there, two more forces I will explain you here. On the surface of airfoil, two more forces I will explain. It is nothing but normal and axial force. What it is called? Normal and axial force. Let me take another color, green one. Okay. So normal and axial forces. So normal what? Normal to the chord. Where is normal to the chord? Normal to the chord. This is the chord here. So normal to the chord, I can say this will be normal to the chord. Okay. 90-degree normal to the chord, and one will be parallel to the chord. Parallel to the chord. Okay. Normal to the chord and parallel to the chord. Parallel to the chord, it is called axial force. Normal to the chord is called normal force. Okay. All right. If this is what alpha, then what will be this angle here? This will also be alpha. Alpha is angle between reference line of aircraft and free stream velocity. Yes. So reference line, in the sense, for if you talk about the aircraft, then it will be the horizontal surface. Okay. If you talk about the aircraft, because this is the basically part of you cannot say this is the aircraft exactly. This is the I'm talking about wing, and in the sense wing in the sense it's airfoil only I'm talking. Okay, all right, but yes, like a part of wing, fine, huh? Now so what I was explaining, yes, for the wing, because where that lift and drag, it will be produced over the surface of wing only, so I'm talking about wing, and the this cross section of wing is what, airfoil, so I have taken this airfoil. All right, hope you understood this. Now separately I will write axial force is what denoted by what, a, and normal force it is denoted by N. So this is the whole I can say the part what I wanted to explain you, like, because if you talk about aerodynamic coefficients, CL, lift coefficient, drag coefficient, moment coefficient, so first you will talk about the forces. From the forces you can get the moment, you can get the coefficients. Okay, done. Again I will redraw this, the small part of the airfoil here. So check, so here I can show you the all the, okay, forces, no? All the forces only. This is what called relative wind, angle will be alpha. Okay, only forces I will show you here. So forces will be, suppose this is the one point I am considering here, so forces will be lift force, okay, drag force, okay, axial force, perpendicular to the chord, normal force. So and resultant of this normal and axial force will be here only. Oh, okay, resultant, resultant of normal and axial R, resultant force of normal force N and axial force A, and obviously this angle will be alpha, because this is alpha, so hence that part also be alpha. All right, now this is the true velocity here. All right, V infinity. So what I'm explaining is very short only. Okay, so I'm going to explain you basically three things as I have mentioned: L, which is lift, D, which is drag, and third is what, moment. Okay, so for the lift, drag and moment, there are various parameters. Okay, there are various parameters, because here if you check, lift, drag and moment will be depending on alpha, yes or no? If alpha you will be changing, magnitude of lift, drag and moment will be changing. Okay, because that component will come into picture, yes or no? So here lift, drag and moment depend not only on alpha, not only on moment, angle of attack, but also on velocity and altitude. Why I am saying altitude? Because density terms will come into picture. Okay, if you are flying at sea level in the sense your aircraft is what on the surface, or you can say it is on rolling condition, or like on runway it is going for takeoff or landing, so it will be considered on sea level condition. It is flying at 3 kilometer or 10 kilometer, so at that time density will be changing. So density one parameter will be there which will affect lift, drag and moment. So that's the reason I am saying altitude. Okay, so this lift, drag and moment basically depend on various parameters, depends on depends on number one, free stream velocity. Okay, in short I am telling you, I am not going for the complete derivation or something. Free stream velocity, which means v infinity. Okay, second, the free stream density, which means rho infinity. And if I'm saying free stream density, it means it directly saying altitude. Okay, third, wing area, because I'm talking here airfoil. Okay, so if there will be area for the wing, if I'm saying wing, then this part will come into picture, yes or no? This will be what? Wing area. Yes, wing area, yes or no? So wing area is one factor where aerodynamics forces and moment will be depending. Then angle of attack. Okay, and called viscosity coefficients. Okay, called viscosity coefficients. Coefficient. Okay, all right, which is nothing but mu. So these are the parameters basically that LDM will be depending. All right, always remember this is very important parameter. So now we can write this For separate part we can write here, like lift L will be the function of all the parameters what I have written. You can write here, it is lift is the function of infinity free stream velocity, altitude, so density will come, area of the wing S, okay, and viscosity, yes or no? Obviously altitude will be there, so temperature will be there, and temperature will be there, then you can say automatically speed of sound will be considered, no issue in that. V infinity, rho infinity, S, mu infinity, and one is very important, alpha, that is angle of attack. All right, so now if you say what is the lift, so basically if you calculate, there is two method to calculate lift. One is by the dimension analysis, okay, which is very simple. You all have done in fluid mechanics dimension analysis, and there you had calculated lift force, okay. If you calculate that, then what you may get, you may get half rho V infinity square S into that coefficient which is called lift coefficient. This was the value. See this lift here, see the function of V infinity, so V infinity came here, lift is function of density which is altitude, so density also came here, S which is the area of the wing, so S also came. You are calculating lift, so that coefficient will be coming, which is called lift coefficient, okay. So now here this part sometimes called Q infinity, okay, S into CL, which is nothing but lift. What is the Q infinity? It is nothing but dynamic pressure, okay. So what is the dynamic pressure? You all know, Q infinity. What is that? Half rho infinity V infinity. You can write half. What is rho infinity? T infinity by R T infinity. Density is what? P infinity by R T infinity. Rho infinity is nothing but P infinity by R T infinity, because we know the formula is equation of state. P infinity, if suppose you want to calculate, it is rho RT. P is equal to rho RT. So what is rho? P by RT, okay, into V infinity square. All right. What is Q infinity? I have written here 1 by 2 rho infinity V infinity square 1 by 2. What is rho infinity? I told you it is P infinity by R T infinity. R is the characteristic gas constant, T infinity is the temperature, and V infinity, okay. What is the speed of sound? It is A is equal to root of gamma RT. If I say A infinity, so it is gamma T infinity. Temperature, T for temperature. You all know this is very basic formula. So here you can say it is 1 by 2 P infinity divided by, this is what? You just multiply by gamma. So here you may get gamma R T infinity. Here in this equation you have multiplied and divided by gamma V infinity square 1 by 2 gamma P infinity. What is the root of gamma RT? Root of gamma RT is nothing but A infinity. So what is the gamma RT infinity? It is A infinity square into V infinity. Okay, 1 by 2 gamma P infinity V infinity by A infinity. Check, both are square na. See, V infinity and A infinity, so make bracket and then write. Okay, all right. What is the Mach number? What is the Mach number? M. It is nothing but V infinity by A infinity. This is the formula, everybody knows, no? What is the V infinity? Local flow velocity divided by speed of sound. Okay, now, so you got M is equal to V infinity by A infinity. What is the dynamic pressure you have calculated? It was 1 by 2 rho V infinity square. Then you have break this in another form. What was that? You got 1 by 2 gamma P infinity V infinity by A infinity square. Yes or no? Check. Only you have seen this step by step. So you can write 1 by 2 gamma P infinity and V infinity by A infinity is nothing but Mach number M infinity square. Okay. So here check, this is what Q infinity, which is nothing but dynamic pressure. So ultimately dynamic pressure is what also depends on the Mach number. Yes or no? So why I am writing this? Because if you check the lift force, what is the lift force? You have seen it is Q infinity S into CL. Na? See, Q infinity S into CL. Na? So it is nothing but 1 by 2 rho V infinity S into CL. So what is the 1 by 2 rho V infinity square? See this value. It is nothing but 1 by 2 gamma P infinity M infinity square S into CL. You can write this. What is the CL? CL is nothing but you can say L Q infinity S, L by Q infinity S, by this formula. Yes or no? L divided by Q infinity. What is the Q infinity? Check. It is nothing but 1 by 2 gamma P infinity. Okay. Mach number S. Check it. Yes or no? You can say it is 2L to L gamma P infinity M infinity square into S. Ultimately what you got? You got that your CL, which is nothing but lift coefficient, okay, this CL will depends on lift coefficient will be the function of, this is asked in your gate, alpha angle of attack, one very important. Here it is proved that CL is also function of Mach number, so we need to write Mach number. And as you have seen, it also depends on the viscosity here only somewhere I have written. It also depends on the viscosity coefficient mu infinity also. Okay, so how much it is viscous, that fluid, how much it is viscous. Okay, it also depends on the viscosity, and you know that because viscosity is not a dimensionless number, so I cannot write viscosity. I just wanted to write because Cl is what, lift coefficient, dimensionless. Alpha, it is dimensionless. M infinity, it is dimensionless number. So one more term will come which will indicate the properties of flow, you can say, or you can say uh, the for the flow analysis we have a different number, right? Like Mach number we have. So this Mach number is what basically used to identify that, or the region of the flow. Okay, region of the flow, like it is subsonic, supersonic, transonic, hypersonic. So what is the region of the flow? So it is non-dimensional, dimensionless number or non-dimensional number. So region of the flow you can get with the help of this Mach number. Similarly, the fluid, basically Reynolds number will be used to identify that flow is what, laminar flow or turbulent flow, transition flow. Okay, so this Cl will come one more dimensionless number which is called Reynolds number. Okay, what is the Reynolds number? Re. So whenever there is the submerged body, if it is moving or it is flying in a fluid, inside the fluid you can say, okay, fully submerged body, not partially, I am saying fully submerged body. So non-dimensional number which is called Reynolds number will be used to study the region of the flow, you can say, or to study the body which is submerged in a fluid. For that also you will use the Reynolds number. What is the formula? Reynolds number is nothing but rho V infinity d divided by mu. So mu infinity, which is nothing but viscosity, dynamic viscosity. So because if it is any body which is, suppose even the aircraft, okay, this is the aircraft. So this aircraft is what? It is completely submerged in a fluid, because everywhere there is the fluid. See, this is the fluid only. No? So this body is what? Completely submerged. See, fluid is what? Flowing like this. So this airplane is what? If you talk about this airplane, so this airplane is what? It is completely submerged in a fluid. Okay, so if any body which is completely submerged in a fluid, then what numbers you will use to study the body, or study the object, or study the fluid? Reynolds number. So the same, I mean, like submarine, one example I will tell you, submarine. Okay, so, or partially submerged body also, there will also be one example. Okay, so Froude number will be used. So many numbers are, I think 5 to 6 non-dimensional number are there, like Reynolds number, Mach number, then Froude number. Okay, Euler's number. So these are the non-dimensional number to study the different regimes of the flow. Different condition will be there. Okay, Euler's number, Reynolds number. You have done this in dimensional analysis in fluid mechanics. So very important point. What is the outcome here? So outcome point is what, the this CL. CL is the function. CL basically depends, I must say here again, CL, which is nothing but lift coefficient. So all here I have written in non-dimensional form. Okay. because lift coefficient it is dimensionless. Why it is dimensionless? Because see this formula only, lift, this is what lift force, and q infinity is dynamic pressure, s is the area, pressure into area will also be force, force divided by force, so it becomes dimensionless. So lift coefficient is the, that's the reason it is called coefficient, like factor or coefficient, these are non-dimensional parameter. Okay, so basically whatever the lift coefficient you got here, lift coefficient, similarly you will talk about the drag coefficient, similarly you will talk about the moment coefficient. For all I am saying, okay, this is the question they are asking in exam, so be careful. Okay, lift coefficient, which is nothing but formula, I must say, lift divided by q infinity by s, lift divided by, what is the q infinity you got here, check, half gamma p infinity, half into s, yes or no? Okay, so here cl basically is the function of, okay, I must say alpha, Mach number and Reynolds number. Okay, similarly drag coefficient is nothing but drag force divided by q infinity s, again this is drag force, again it may come 1 by 2 gamma p infinity m infinity square s. Okay, and it is also the function of, it is also the function of same alpha, Mach number and Reynolds number. They are asking, okay, in examination. So this, now this is the moment coefficient. You need to write moment divide by moment equivalent, q infinity s will be the area, you just multiply by the chord, chord is the length, chord length. Now chord, this check, q infinity into s is nothing but force and chord is the length, so force into length will be moment, this is the moment. So moment divided moment will be moment coefficient, it will be m divided by 1 by 2 gamma p infinity Mach number, this m infinity is the Mach number. Okay, because this m is, I am writing moment, it is m infinity, m infinity means Mach number, m means moment, s into c chord. So this is also function, it indicates function of, again L, alpha, m infinity and Reynolds number. This is very very important, you all need to remember this. So what are the aerodynamic coefficients you got here? Lift coefficient, drag coefficient, okay, and moment coefficients, fine. And and its dependency also you have seen, like lift coefficient depends only on angle of attack, Mach number and Reynolds number. Similarly drag coefficient also depends only on angle of attack, Mach number and Reynolds number. And pitching moment or moment coefficient you can say depends on the angle of attack, Mach number and Reynolds number. This is very important here. Okay, they are asking examination. Done. I think up to here it is very clear to all, right? So fine.